Welcome back to the channel where we build a video game from scratch using Love2d and Lua. So yesterday we had some collision detection implementation. It was for the map collidable objects such as the tree here. And we had a viewer yesterday, the Stilkin, who suggested a good idea, and it was to add perspective-based collision detection so that since it's a top-down view, we should be able to get a bit closer to this tree. So instead of perfect collision detection here, he suggested, or they suggested to, scoot the hitboxes down a bit so that we don't detect a top collision as soon because of the top-down perspective, which makes a lot of sense because if you look at it right here, we should be able to walk past this tree, and we can't because if you look at the squares, they interact or they intersect, so we can't walk by it. So I think that's a great idea to add. So we're going to be adding that. And I do want to give just a big thanks to everybody who is a follower on the channel, because yesterday we hit 40 followers, which is a huge, huge feat. And we are close to our 50 follower goal to get affiliates so we can do channel points and all that fun stuff. Custom emotes and really up our game, so that'll be fun. Let's take a look at the collision detection we did yesterday. Now I think it's in our entity class. Yeah, it looks like it is. Okay, so we took apart. We used to have true AABB collision. That was this collides function. And then yesterday we added specific collision. So I'm going to pull up a sprite here. And oh, you know what? I think I didn't save it. Yep, I didn't save it. Let's remake what we did yesterday because we're actually going to be switching it up. So yesterday we drew a little example of what our collision detection would look like. So we gave ourselves a 2 pixels wide rectangle, but we left 2 pixels empty on all the corners. Like we left a square pixel of 4 there in every corner. And that was because, you know what? Let's get that. Okay, so this is what our current collision detection looks like. So we've got our top and bottom and left and right. Now, we have to leave these gaps here on the corners because we don't want any overriding of these collision detections. We want to know, hey, this is a top, hey, this is a right. So if we collide on the right first, as long as we're not 2 pixels in, we shouldn't be detecting a top collision. So that'll get rid of our order of operations problem, which if we had it flush all the way like this for one side, if we had it like this, then we wouldn't be able to detect top collisions and top collisions only. So it would kind of default to whatever we described first. And we don't want that. We want it to be clean, but we want to shift our hitboxes down. So I guess the first order, it's going to be something like this, right? Where we're going to take all of these and shift them down. So something like this. Let's see. So if our new collision detection is something like this, our sides and our bottom remains unchanged, except that the top collision is just moved down further. So that hopefully would give us a little more wiggle room to walk in front of something without, and our head be over it because of the top-down perspective. So I'm kind of curious if we were to just draw this top. Like if we tell our player class to just draw this rectangle here in this location and just see, we'll take off the collision detection removes or or position movements, and we'll just see what it looks like for that to be a collision, because we might need to scoot it down a bit further. I don't know if that 2 pixels is enough. So we'll take a look at what that might look like. So if we go into our scene here, we want to go where we're doing all of these collision detections, and we're just going to turn off the X and Y position resets so that we're not actually preventing us from walking anywhere. So we should be able to just walk over the tree again, but we should still be able to, we are still running those functions, so we have access to do something. So I think what I want to do is we want to render, and we have access to our self.player. Okay. So what we want to do is if we top collide, actually we're going to say, we're just going to snag all of this from our update function. Actually, this is in our render function, right? Yeah, okay, so that's perfect. We need it in our render function. And what we're going to do, instead of setting our Y position upon a top collide, we're going to render that square, that updated top collision detection bounding box, and see what that looks like. So we're gonna do a love.graphics set color, and it's gonna be red. And then we're gonna be doing a love.graphics.rectangle, and we know that the first argument is a fill type, which we want fill. And then we want to give it the X, Y, width, and height. So let's plug in our player X. And we want it to be a player X plus 2 because of the 2 pixel side buffer there. And then the Y is down 4 instead of plus 0, which it used to be. So we'll see if a player.y plus, and it would actually be a plus 2. Because it starts 2 pixels lower than the top, so I think that's actually right. And then the width is going to be a tile size minus 4 for 2 pixels on each side, and then a height of 2 pixels. So now if we top collide with these tree, we should render a little hitbox. Okay, maybe red is a bad move because our hair is red, so what we'll do is we'll do green here. Cool. So the question is, and now we have to keep in mind that this is the old collision logic. So we'll detect a collision here, even though our hitbox is lower. So the question is, if our hitbox were to be scooted up where it was actually colliding that tree, is that good enough? So right here, it looks about flush, and our head is a tiny bit above the tree or in front of the tree, but I do think it needs to be a little closer. Like we should be able to get about here, or maybe even further. Yeah, we might even want to go here, because like this, it looks like we should be able to walk in front of the tree right here. So I don't want to push this too far, because I mean, it does look, I mean, it kind of looks like we should be able to walk even here, right? So dude, it's messed up for me because I get the non-laggy version if I look on OBS. So there you go here. I feel bad for cheating. Okay, so I think something like this, which is actually a lot lower than we thought. Now, you know what? And I think if we project this out to when there's bad guys and there's other stuff flying around the screen, we want collision detection potentially to be right with the top of our head. Because if we imagine not us being in front of something, but something coming from the side here, like if my mouse is a projectile and it hits where the top of my head is, it should render a collision detection. So I think we want to apply our player position clamping logic only for map collidable objects. Everything else can be either true ABB or slightly shrunk AABB. So I guess the next thing I want to do is we'll actually try to place this proper for the map object collidables. So we want to not do it +2, but at least +4. We'll see what that looks like. See if that allows us to walk. So with a +4, this would render a collision, meaning we can't walk. And it should be. So I'm thinking it should be +6. It should start 6 pixels down, I'm thinking. Okay, that's looking better. So now if we flush that green with the top of the map collidable, we should be able to walk in front of the tree right here, which looks about right. That's looking good. So I'm thinking +6, which is different than +0, which we used to have. So let's see what that would look like in A-Sprite. If that is 2 pixels, look, we go 1, 2, 3, 4, 5, 6 is where it would start to draw it. So it would go past, gosh, it looks so low, but, oh. Yeah, we would start drawing it at the 6th pixel there. Gosh, that looks so low, doesn't it? It was so cool. Yesterday we got like 4 followers in the second half of the stream. That was so cool. Gosh, that looks so tiny, doesn't it? It looks so jacked up. But for map object collision detection, it makes a lot of sense because of the top-down perspective. So I think Stilkin was right on that. I think that's a good idea. So it just looks so weird. And another thing, if we go and we turn on our position resets upon those collisions here, which are in our entity class. Yeah. We want to do... No, it isn't here. Where is it? In our scene? Okay, so look, we'll take this off. So we'll go back to doing our old collision, and we'll just look at our left and right sides. So like yesterday we noticed that we're able to go like 1 pixel further, but our reset should be our nose is flush, not a nose back. So I'm kind of curious if in our collision functions, I'm curious if we put on these less than or greater than, if we put in equals or equal, less than or equal to. So I'm kind of, let me see if we highlight all of these and we replace it with whatever this is, but equal to. Then we try that again, and we'll just do it for these ones. Substitute less than with less than or equal to, and then we want to do greater than with greater than or equal to, so we'll go substitute greater than for greater than or equal to globally. Okay, let's try this and see if that changes where our nose ends up. It doesn't. Okay, so I guess... that means when we do... Okay, I want to undo this and undo that. I guess that means when we reset our position. And it's... Okay, so if we take a look at our actual sprite for our character, there is a gap there. So it makes sense that it would reset with a gap. But... we probably shouldn't... Let me think. So look, if we right collide like we've been, we're setting our X to be this, and if we add a +1 here, we'll forever detect a collision because our collision detection is getting reset to be inside a collision. Okay, so that was a little weird. Yeah. Okay. So I think we want to shrink. I think we want to shrink at least the left side of us by 1 pixel. See, and this is where it gets a little messy because we're doing this in the entity class. And not all our entities will have a space on the pixel for their nose there. So I don't know if that's okay. I mean, it kind of bugs me that when we're walking forward, his nose is flush, and we let go and he scoots back. But we will have a different animation for when you're pushing up against a collidable map object. Yeah, this is interesting. So when we hold it, we're updating our X position, and then we're setting our... And you know what? I think we might be setting our position before we detect collision, which I guess... Let me see. Yeah, we do it in our... Well... I had a depot in the jail today, so I had to wake up really early and get to the jail and do a depot in the jail today. So if I look like I'm zoned out, I am. Okay, this is really strange. I guess it's kind of weird that we're doing... I think this explains stuff, because we're updating our position in the render function for our scene, which is just weird. We shouldn't be doing that. Oh, see, look. We render our entity, and then we do the collision reset. So I think if we were to swap those two things, it might fix that problem. So let's see. It does not. I do think that this is a not good idea, though. I think we should just render it here, and then we should... It's nice because we wanted to test this with a render, but this really shouldn't be in our render function. It should be in our entity update, which currently doesn't have a lot of stuff. Oh, okay. So yeah, it should be in our entity class, because we're going to be updating the entity here, it should be in our entity class, to be honest. So we've got those functions defined here, and then in our entity update, because then we're deferring it to our state machine. I guess that makes sense though, because that means we can have custom, if we're deferring it to our state machine, we can give our player walk state a specific collision instructions, and then we could make sure that our other entities have normal AABB. So that actually kind of works out. So we want not entity walk state, but oh god, undo. We want to go to our player walk state. Okay, now in our player walk state, we're going to do this, and we're going to but do we have access to our current map? We do not. We have the scene, so we have to go, when we cycle through, we have to say not self.currentMap, but self.scene.currentMap, .collidable map objects, and then same here, scene, current map, collidable objects. Oh my god. So what we can do here is just highlight all this, substitute any current map with self.scene.currentMap. Okay, so now we're running the bottom collides on the player function, and our player, we should have access. Yeah, we have access to our player. So that's all good. Okay. So now we're doing these collides. Now the thing is, this collides is an entity function, but what if we turned it into a player function? Because right now, I think it would work. Maybe not. Okay, that's just totally broken. We've got access to our self.scene, no? We pass it in with the player walk state. Okay, I might be in over my head right now. Okay. Okay. What if we don't do that? Let me see in our scene. Okay. I guess I'm just trying to think of why it would do this. Why would our X position be... Oh, it makes perfect sense. It's because our walking animation has a nose forward. Our nose is forward in that walking animation. Okay, that makes perfect sense. So it is working right, it's just that our sprite sheet is just inconsistent. This might be okay, because at the end of the day, we are switching our walk state to be a push state if we're holding a direction into a map object. Because look at here. We've got a pixel gap on either side of his head, and a pixel gap. You know what? Hold on. No, it does have a pixel gap. It does have a pixel gap on the walking, so something is messing up. We shouldn't be doing that. we shouldn't be shifting his feet or his nose. And you know what? I've been curious if I could pop out the waveform for Sonic Pi here. Where is the waveform? I was always thinking it would be cool to put the waveform on screen here. Oh, there it is. Gosh. Okay, here we go. Come on. Preferences off. Let's pop this bad boy out. Okay. Minimize you. Okay, that minimizes everything. So maybe we can't do it. I thought it'd be cool to kind of pop this out and leave it on in the background. Why can't we size it though? Oh, yeah, we can. Okay, see, look, I like that. What if I put it... Oh... Why does it do that? Oh, God. Why does it do that? Well... Okay. I want it to be like... Damn it. I don't like that it says scope. Like, I wonder if there's a Windows plugin to get rid of that. The top window bars, because I hate those top window bars. But I'm thinking we can kind of, yeah, see how it's kind of, we can leave it maybe right here. Is that weird? I don't know, it's kind of distracting, I guess. I think it's kind of cool because it's running in Sonic Pi, so like that's the real waveform for it. So I like that aspect of it. We'll leave it on. We'll see if we like it. I do want to see if there's a Windows plugin to get rid of that stuff. The top window bar. That is kind of cool though. Okay. I guess it's just a question of does it disappear if we do this? No? Okay. Well, we'll see. So what is weird is we are messing this up. We shouldn't be doing... Oh, it covers Sekijo, though. I don't like that. We won't cover Sekijo. Yeah, we shouldn't be sliding us back here. I think that's an issue of our placement being after the render. It has to be, but I don't know. I don't know, maybe right under chat. Okay. I swear this bug has to be because we're rendering before we update our position. So look, we render our entity, and then we're going to go and reset our position after this. So what was weird was it didn't fix it to just put it in our update function because we actually... And actually, let's try just taking it out of the render here. So we'll take it out of the render and we'll put it right here at the end of our update function. So now we're updating our player X and Y first based on the collision, and then we render it. So it should reset our position to the appropriate one gap and then render us. So we shouldn't have that issue anymore. Let's see. Oh God. Nice. Okay, that does fix it. But but we can't even walk up to the tree. It's our nose. Our nose is touching it. So I think what we want to do on top of our top-down collision addition, because like, see, look at that. We should be able to walk there. I think what we want to do also is to go. I think we want to shrink our hitbox here by 1 pixel on the left and right. And then 1 on the bottom as well, because we should be able to kind of walk over. So I think, okay, so here's the move. We pull these in by 1 pixel each. And then we move this up 1. So this would look like this. Except, yeah, let's see. It looks so jacked up, but this, and if we have 2 pixels here, we want this to be white, this to be white, this to be white. Okay. So I think this is our updated collision detection for our map objects, for our player and our map objects. I think that's okay. So if we make the equivalent of this in our collision detection code instead of the old one, which was only on the very edges, then we should have a more responsive, what you want to call it, more responsive collision detection. It should look better. So let's go for this. Now we need, I almost need to write this down. It's like, I don't have a pen and paper, of course. Okay, well, it's gonna be, the top boxes are 3 pixels instead of 2. 3 pixel gap. And then this was 6 pixels down. Yep, and then this is 1 pixel up. So we just have to kind of remember this. Oy. Yeah, you know what? We'll leave this up as a reference. We'll do that. Yeah, we'll just leave this up as a reference so that we can refer to it, and then we'll just put it in the back there. Okay, so now let's take a look at our entity class. Now I do like the idea of separating this into a map collision function instead of just a top collides. It should be like a top map collides, because it's different. You know, if a fireball's coming at us from the left or right side, it should register a hit if it scrapes the top of our head, whereas if we're in the map, we shouldn't be able to walk over the tree, you know. So I think we'll end up doing that, but let's go ahead and see if we can modify our entity collision detection based on this. So instead of, I think instead of doing it should be left, I want to say map object, but that's too many words, right? I mean, left map object collides, right map object collides. I think that's okay. It's just that I know we don't want this for all of our, you know, like we need collision detection for our entities that is different than this. So I'm just gonna try to get in front of it and just make sure we give ourselves a different collision, because we don't want to just say bottom collides. It'll be misleading, because it's not a true bottom collide. It's like a player colliding with the map object collides, so we just want to change it. Which means we have to redo all of our collision detection code from yesterday, but that's okay, because we know how to do it. So we'll leave the true AABB just for testing purposes. Now we're going to gut everything. We're just going to gut all of this. Because I feel like looking at the code would bog us down. So we're just going to do it. Okay. So what we need for left map object collides now is it's an entity collides on the left side. So it's like, it's almost like left collide map object is a better word, because like left map object makes me think a map object but the left side of it, but it's actually a player left collides with a map object. So I think this should actually be, I think we should change this to be, instead of map object collides, it should be collides map object. I think that makes more sense, because then it says left collides with what? A map object. I think that makes more sense. So for our left collision detection, we want to make sure, now our target is the map object. So we'll say, you know, the left side of our bounding box, which would be a self.player.x plus 1 pixel buffer for that nose. It'll be the left side of that box would need to have to be greater than the target's x plus the target's width, or the right side of our box, which would be self.player.x plus 3, because it's 1 pixel for the nose, 2 pixels for the bounding box. We would see if the right side of it is smaller than the left side of our target. So target x, or, and then here's where we do the y's, and we say the top, now this is still for the left collision box. Yo, get that star, get that star. The top of our left bounding box, here's where it's a little tricky now, because this is why the reference is so handy, because we can say, we know it's 6 pixels from the top, plus 2 for the buffer for the top collision. So we would say the top of our bounding box on our left side, which would be player.y, plus our 6 plus 2, so it would be plus 8 here, would need to be greater than the bottom of the target. So it would be target.y plus target height. Or the bottom of our box, which would be a self.y plus a self.height minus 1 pixel for the foot buffer and 2 for the, and actually, yeah, we drew this diagram wrong. We want it to be, these should be white here, these should be white. So it should look like that. So we would want the bottom of us to be smaller than, and the bottom is this minus 1 pixel for the foot, 2 pixels for the bounding box, so that's 3. And that would have to be smaller than the top of our target in order for a left collision to be impossible, and then our function's returning the opposite. So Now, if we run this left collide map object with the target of every map collidable object, we should be able to tell if we did that right. Let's see. We need to run our function here. So we'll go to our scene. We'll go to the update function where we're doing it. And instead of these old functions, we're going to be detecting a left collision. So what I'll do is I'll turn these off for now, these old ones, so we don't accidentally get behavior we don't want. And then for the left, and it was left collides map object now, then we're going to set our x to be the object's x plus the object width. Now we also want to subtract 1 so that our nose is flush with it, because our bounding, or our left box detection has a 1 pixel buffer, so we can actually now put us a -1 pixel closer on the right side of that, and we should be okay. And top collides crashes. Did we take out? Oh yeah. Let's get rid of all this. Actually, I just hate deleting stuff before we know we've gotten rid of it. So really, entity 39 index a player nil value. So entity 39, let's take a look at our entity, and it should be self, not player. Oh, yeah. Instead of player, it's actually just self. So we can get rid of all the players here. Substitute dot player with nothing globally. Okay, self.y. Okay, that should be it, maybe. Yeah, that should be it. So let's see if our left collision detection is working now. Okay. Okay, this is great. So look, he's a tree sniffer still. We're not getting that extra pixel of closeness, but we are stopping at the appropriate space. And then we should be able to, we should be able to get 1 pixel of overlap for our foot there, which we do. Now, I don't know if I like that, actually. Yeah, I don't think I like that. I don't think we should, we shouldn't be able to do that. So we should adjust that. We should, so we do have to change some stuff here. We got to move this. We got to move this back down, which would mean that this would look like this. So we got to change the height of that left box to be 1 lower, and then we should be okay. But that should be our new collision detection for at least map object collidables. God, dude, making a game is so much work. Like, it takes so long to get anything done. Okay, so yeah, we're seeing if the left side of us is greater than the right, the right side of the other one, or the right side of us is smaller than the left side, yes, or the top side of us is greater than the bottom, yes, or the bottom of us. So here's where this needs to be just -2 instead. Okay, so that should fix our 1 pixel foot buffer here. So we should, oh no, okay, well. Okay, we won't be able to tell until we have our bottom collision. But that's okay. So we're on the right track. Oh, and check that out. See, look at that. Look, we can't walk through the tree here, but we can right here, which looks about right. And then, yeah. That looks just about right. Yep. That's cool. So yeah, now we can walk in front of the tree like that. Like Stilkin suggested. That was a good suggestion. So, last night, I believe, yeah, I think it was Stilkin actually, was our 40th follower. And he did it as soon as I was raiding Practical and as soon as I swapped to my away screen. So we didn't get to see our goal met alert on stream, but I did confirm it because on our thanks for watching page, we have the stream avatars, and our avatars danced right as soon as I switched it over. So that means they dance whenever there's an alert coming in. And what was cool was when we got raided, the plane dropped a bunch of bombs. I didn't see that till I watched the replay, and the raid dropped a bunch of bombs on our avatars and they went wild. That was fun. See, yeah, I feel so much better about that. We should be able to get like that close to the tree. We should be able to walk in front of the tree like that. So I think that's a great addition. Okay, let's see how fast we can bust out these other collisions. And then we do have to make a better tree. It's a bad tree. Maybe we'll do that today. I don't know. Okay. Return. Not. Okay, the first thing we do is check the left side of our collidable, and our left side is going to be a self.x plus a self.width minus a 3. 1 nose pixel buffer and 2 for the bounding box. And we're going to see if the left side of us is greater than the right side of our target. So target.x plus target.width, or the right side of us, which would be a self.x plus self.width minus a 1 would be smaller than the left side of the target, which is a target x. Then we check our y's, and we would make sure that the top of our bounding box here, which would be a self.y plus a self.height minus, and actually instead of adding the height, we would just add the 6 pixels for the, okay, it'd be plus 8. 6 pixels plus 2 for the top bounding box. We would see if the top of our box is greater than the bottom of our target. So we'd say target y plus target height, or the bottom of our box, which would be a self.y plus self.height. The bottom of our box would have to be also smaller than the top of our target. I believe that's right. Let's go ahead and keep going. Let's try to do our top and bottom collides too. So we'll go return not, and it'll be, we want to see the left side first. So our self.x plus 1 pixel for our nose, 2 pixels for our bounding box. That's our left side. We would see if our left side is greater than the right side of our target. Or the right side of our top collides, which would be a self.x plus width minus 3 would be smaller than, the right side of us would be smaller than the, hey Stilkin, hey, it's going good. We're actually implementing your idea here. You had a great suggestion yesterday, which is to shrink the top collision box for our player so that we can walk in front of the tree. So the A sprite in the background, those are our new collision detection boxes for our 16 by 16 sprite. So that should give us the ability to walk, you know, a little overlap with the tree. So we're almost there. Okay, we check our Y for our top collision, and it would be self.y plus self dot, or it would be plus 8. Well, I guess we want to check the top of us first, so it would be plus 6, and we want to make sure that the top of us is greater than the bottom of our target. Yeah, you having a good night, Stoken? Yeah, so far so good. I'm a little sleepy, so it's hard for me to keep my eyes open, but I'm glad to be streaming, so probably won't be more than an hour long from now. I'll probably call it before an hour more, but we'll see. Okay, so now we need the bottom of our top collision box, which would be self.y plus our 8. We'd want to see that that is smaller than the top of our target. Okay, so that's looking good, maybe. And our last one. So yeah, we gutted all our collisions from yesterday, and we're doing your idea, Stilkin, so we'll see if it works out good. Yeah, I know, yeah. There is like there's like a willpower stage of that, but then there's also like my eyeballs are literally can't stay open, and I'm like about to cross that threshold, so I'm gonna be not able to keep it going much longer. Okay, so left side of our bottom bounding box, which would be self.x plus 3, would have to be greater than the right side of our target. Or the right side of our bounding box, which would be a x plus our width minus our 3. And I'm sure there's a way we could put in, I don't like kind of like putting in these magic numbers here, but we're still kind of testing whether or not this is correct. The right side of us would have to be smaller than the left side of our target. Now the top of us, it's the top of our bottom bounding box is what it really is, which helps that we have it on screen here, because we have to say it'd be the self dot, the bottom of us minus 2. The top of us would have to be greater than the bottom of the target. Okay, or the very bottom of us would have to be smaller than the top of the target. Okay, this should be it. So we've got our functions declared here in the entity class, which I still have my reservations about, because I mean, at least we have it Because if we have a bad guy, we would also want the bad guys to be able to walk a little bit overlap because of the top down. And yo, Stilkin, if you want to be anyone other than a Ditto, I can give you some money to buy something other than a Ditto. See if I remember that. Okay. Alright, hey, Ditto's fine, man. But there's 30 gold if you want to mess around or get a Marvel character or something. Okay, oh, so here's the thing. We declared the function there, but we also need to move our character based on the result of those functions, which we've got only our left collides map object. Now, we gave ourselves a different, instead of just left collides, we call it collides map object because if a fireball or something's coming in from the left or right side, we don't want to shrink that perspective hitbox. We want it to actually hit our head or whatever. So we want different collisions if it's not a collide with a map object. So I think that's why we named it like this. And then this is just in our loop where we're going through all our collidable map objects, which gets populated based on the current scene's tile IDs. Now we have to put any collidable map object in a certain range on our map atlas or on our master sheet.png for this to work. But it is cool because like no matter where we put a tree, that tree will be a collidable object and we can't walk over it. So I can maybe demonstrate that if this ends up working. So if we right collide with an object, we would move our X to be the object's X minus our self.width. If we top collide, we would change our Y position to be equal to the object's Y. Oh, and here's a little, since we've got this this new bounding box, we've got to put this in the right spot. So like we want the top of our top collides Y, we want that top collides Y to be the very bottom of our object. So we would want to set our Y to be equal to, if we set it to the bottom of the object, it would be too high up, but let's for now set it to the bottom of the object. So we'll say the object Y plus the object height. And we have the object variable here, so we don't have to say self.currentMap.collidable map objects at the ith index. It's top left, so Lua or Love2d is top left is 0, 0. So going positive on the x-axis is right, positive on the y-axis is down. So I'm not a super huge fan of that, but now I'm kind of used to it now because I've done a couple years of Lua programming, but I'll have to unlearn that again when the next game engine does it the other way, you know, origin bottom left, which makes a lot more sense, like growing up with math stuff. I guess it makes sense kind of from like a terminal perspective in the sense that we start reading at the top from left to right. So that's how I kind of remember it, is like, oh, if you're going to read a book, you start at the top left, go read to right, and then go down. So we don't want to move the top of our player to the bottom of the object. We want to shift it up by these 6 pixels so that we're flush but not colliding with our object again. So that should be it. It should be that -6. And then if we bottom collide, we're going to move our Y to be not the object y. Well, it would be the object y minus our self.height. So let's see if this is right. Okay. Field width, scene 159. Okay, yeah. It's a self.player.width. And then same with here. Okay, we don't have the 1 pixel of nose room that we should have. We do have it on the left, and our bottom collision is not working. And our top actually is, so check that out still. We can walk in front of the tree now. But our right is off, and our bottom is off. Yeah. It's getting there. It's getting there. Yeah, that was a great suggestion. Now, I don't know where we messed that up. It's got to be in the function definition here. Because if we're moving to the left here, that means our bottom collision is just not working. It's detecting a right collision there, which is why it's moving us to the left. So we need to get us 1 pixel closer on the right collision. So instead of a player.width, we need to minus a 1, just like we minus the 1 for a left collide. And actually it's a +1. Move us to the right 1 pixel. So now we should have a flush nose against the tree, which we do. And then our top collision is working, so it's just our bottom that's messed up. Okay. So let's go take a peep at our bottom collision, which would be in our entity class. And it should be right here. So we're gonna see if the left side of our bottom collision, which is x + 3, is greater than the right side of the target, or if the right side of our bottom collision, which is right side of us -3, that's all correct, is smaller than the target x. Those are right, so we must be messing up the y here. We're checking the top of our bottom colliding box, because it's a -2. Top would have to be, oh, here's where we're, well, yeah, the top of us would have to be greater than, see, this is wrong. The top of our bottom bounding box would have to be greater than the gosh, my brain is just breaking on this. Because we're returning a knot here, the opposite. We're asking what is impossible for a collision, and then we're returning the opposite. So if the bottom of our we're asking if the top of our bottom box is greater than the bottom of the target. Okay, that seems right. Or the bottom of our bounding box, which should be our self.y plus our self.height, would be smaller than the top of our target. That all seems right. Self.y plus self.height. This -2 is because it's the top bounds of our bottom collision. We're checking, like, because for a AABB collision, we've got to do the all sides. So this represents the top side of our bottom bounding box. So if we ignore all these other ones, it's just this one. So it's a self.y plus self.height minus 2. That's this top bar. But let's compare it to our top collides and see what's different. We're asking. You know, I don't know what's wrong about it. Are we doing... We might be asking... Maybe we didn't shrink our left and right... our left and right collisions. Let's check the top of this. Let's see, left collide would be... Well... So a right collide, it would be the self-y plus 8. Yeah, that is... So, like, the... No, this is wrong, this is wrong. Yeah, it wouldn't be plus 8. It would be... No, this would be... No, yeah, this would be plus 8. But then this, y plus self-height, this is where we're messing it up. This should be a minus 2. And then left collision. See, look, left collision has that minus 2. So that should be it, I think. Okay, cool. I like his little shuffle. Okay. Okay, cool. So we've got flush tree sniffer there with his nose. And then we can walk a little bit in front of the tree. Now, I feel like that's a pretty good... Still, can you think that's a good height for him to walk any further? Because it really looked... The, like, that feels pretty good. That he can kind of do that. Yeah, that feels pretty good. Because any smaller and these hitboxes start to, like, not look real. You know, like if we shrink it one more pixel, it looks kind of weird. So I think that's kind of the sweet spot. Okay, cool. So we've got updated collision from yesterday, and it's looking real good. So now I do want to kind of show off the cool part of this is, like, let's say we want to redesign the map. We would go to our declarations. And we would say, you know what? We want a tree in the top right. So we're gonna, we're gonna go here and put a tree top left. Oh my God. Tree top left, and then tree top right. And then a tree bottom left. And now all these are our numbers for our quads to draw. But we're actually treating those numbers from the map as potential spawns for collidable map objects. So anytime there's a tree there, we're automatically detecting collision for it. So anytime we, like, let's say we build a fence or a wall, all we have to do is make sure that we place it, and I'll show you guys the code here, like in our collidable map objects. Okay, well, that's our class. We want to go, I guess, to our, where did we put it? I thought it was, oh, it's under a map instantiation. Because anytime we transition, we instantiate a new map, and this is it. So this is the code right here. We're saying we're checking for a certain ID, tile ID value, and if the tile ID is in that certain value, we're gonna insert into our collidable map objects table a collidable map object. So the 97 to 224 comes from our master sheet. So if we take a look at our master sheet, right now we've only got a tree there, but that 97 to 224 means that any sprite that we put all the way to the end of our table and 2 rows beneath it, all of those are going to be dedicated as map collidable objects. So we can go in our game and we can just place, and anytime we make like a wall or fence, we just put it in that range in our sprite sheet and we'll automatically detect collision for that map object, and it'll have the same kind of perspective-based collision detection that Stilkin recommended. So I'm pretty excited about that. It's looking pretty good. Like our tree, we need to make a better tree, obviously, but that is looking pretty good. Yeah, man, shoot. Go ask a question. Oh, we do need to stop updating our Manus bar if we are transitioning, so we can go do that. Tolkien says, if, say, you encounter any of these objects from above, can you fake a Z order by redrawing that tile after the player on their current tile and faking them behind the object? Yo, that's a great idea, Stilkin. Because that, like, it's the opposite of the effect we're getting here, which is, you know, we're over them, but if you're saying, like, right here, we can actually walk behind the tree, and the tree would go on top of us. It's a little weird because at least our current sprite has that baked-in color. It's got a baked-in yellow color. So what we're actually doing in our whole game is populating every scene with desert right now. So like all this desert is actually what we first put in every single level of our 1010 maps. And then we render the tiles over it. So if we do that with transparency, like either the yellow would appear right on top of us and the illusion would be kind of ruined, or we make those transparent. But then we still need to know what kind of value, what kind of color value needs to be behind it. We could make it so that every tree has a grass color background, but that would limit us to only putting trees where grass is right around it, so that if we walk behind the tree, it would be a seamless illusion like that. So I love that idea, but I'm not so sure how we would do that with that element in mind. Because we're gonna have different biomes, like, you know, we're gonna have like we're gonna have like a forest, we're gonna have a sand, we're gonna have a snow mountain, and depending on which, you know, I mean, I guess we could do it like only these green trees show up in the forest biome or whatever, and then we can just make, I don't know, it kind of limits us, I think, because right now, and this is a lot like how Pokemon and Link's Awakening does it, where since they're not square objects, they have to give it some sort of corner pixel color, and they kind of just put it this yellow color, which is the color of the borders and stuff. So, you know, I'll make a note of it because I think it's a great idea. And if I can think of a way, once we actually get some level design working, then I can decide if we want to go to it. With the 8-bit look, you wouldn't expect to go behind the trees. Yeah, I mean, Not necessarily, no. I mean, what's cool is like, you know, we can make up our own rules because we, you know, it's our own game. So like, I think it's a cool idea, and I guess with proper Duck's logic, like we wouldn't be able to walk in front of a tree like this either. But we can kind of do what feels right. So I think I think I like being able to walk in front of the tree. It helps kind of sell the top down perspective. But yeah, we probably won't do the walking behind, even though I love that idea. And maybe we'll do something different. Like maybe we'll do it. Although wouldn't the player be the second layer above the ground, but below the transparent? Well, that's the thing. We're not rendering a base ground first. It's not like a sandwich. We're not doing like a ground color and then our player and then the tree, but that could be. Yeah, it's like how we have it set up is our map declaration is a tile ID of all these different numbers. So like we're only doing it once. And the exception is we default it like, so here's all those values of the tile IDs we're actually giving it. So we're only really doing this once. The exception is we go ahead and first populate sand for all of the maps first, just so we have sand to walk in, and then we're overriding the map 1-1 with all this stuff. So we would have to come up with a new system to kind of do a sandwich like that. But I do like that idea. We'll type it down just as an idea for maybe we have like tall trees that go in front that have a perfect transparency or something, like, and those are separate from our map tile sets, you know? Like that's one way we can do it. We can make some tall pine trees in the foreground or something that you can walk behind. So maybe we can still implement that just through some other idea, not through our main tile set implementation, but okay. So yeah, I'm gonna see if we can't figure out how to limit our Manus usage if we're not. We don't need that many geckos either, but we shouldn't be able to drain Manus when we're scene transitioning here. So let's take a look at where our Manus even is. Is it in our scene? Did I really just... Okay, it looks like it's in our play state. So when we this is all of our Manus update. So we can go ahead and I guess in our play state, do we have any reference? We don't have a reference to the scene change, because that's being taken care of in our scene view. So I guess we'd have to move our Manus into our scene class in order to stop updating it if we're transitioning, if our scene's transitioning. I guess, is there a way that we're asking... If there's a way that we can ask if the scene is currently transitioning, but from our play state, then we can kind of only update this if we're not transitioning. Let's see, and I think, you know what? I think in our scene class, I think we do have a variable that keeps track if we're shifting. So we should be able to do this. We should be able to say, we'd only want to do this if our self.sceneView, and actually it's just sceneView. If sceneView, if not, sceneView.shifting. Then we're gonna go ahead and update our manus and stuff. And then maybe that will be enough. Let's see. So if we're draining our manus, I'm holding spacebar. Yeah, it pauses when we're transitioning. So now we can't accidentally waste our manus if we're transitioning, so that's good. Cool. Okay, so I think what's on the table for next episode is rehauling our animation insertion function, because right now these flowers aren't animating anymore, and that's because I just hated how bad it was when we implemented it. It doesn't make a lot of sense. So like the hard part with animation is we need to be able to update the frames over time for our scene. But we need to be able, hopefully, to just be able to declare one value in our map declarations. So like ideally, there's a thing called a flower, and that flower is an animation. And that animation gets updated over time. So hopefully we would just be able to declare this once, say, hey, there's a flower here, and our game knows, hey, flowers is an animation, so here's the different quads, here's the rate to animate it. So we did have a thing like that, and I guess let's see if we had flower anywhere in here. Okay, flower is the quad of the first flower sprite, so that's why the flower sprite's in there. And then when and this is the other thing we did, was like we hard coded it here. This is so gross because we gave ourselves a flowers object. We made a function called animSpitter that takes in a start quad and an end quad for our animation and a rate to animate it. And then we update that object over time, and then we manually insert it into the proper column. So it's like, that is so gross, because we're gonna have, if we have multiple animations, we'd have to do this for every single map. You know, like we're doing this. This is the flower inserts for just our map 1-1. This is just our map flower inserts for our map 1-2. So we have to rehaul this. I might have to think about how to do that though, because it took me like an episode or two just to get the animation working like this. Because we need to update the frames over time, and we only need to update the frames in a certain X and Y at a certain quad ID, certain range, certain time rate for animating, and then only do that if we're on the current scene. So it's a lot of logistics to try to keep in mind. So I think we might just end up gutting a lot of this and just kind of rehauling it. Can you make your flower sprite 2 tiles wide or tall, but only show 1 tile worth? Yeah, I mean, that's essentially what this animSpitter is doing. It's just that the actual value that we're populating into our map declarations is only a number. It's not an object or anything, because how we're rendering it is by tile ID, which is the quad. So we kind of have to keep that forward if we want to render our map how we currently are, which is by our ID, our tile ID. It's a lot. It's a lot. But I like your thinking. Like you are on the right track. Like, yeah, we're probably gonna have to redo this because this is just so messy. I want to be able to say, it's almost like we have to make our flower not a constant, but a variable that just gets updated over time, like you said, shifting the quads. So maybe instead of doing this whole insert animation, what we do is in our constants, or yeah, it wouldn't be a constant, but where we declare our constants, we would have an update function, and we'd go ahead and give us a variable, not a constant, but a variable of this, what I call anim spitter, which is a terrible name. That just means it spits out the animation over time. So we give it a starting quad, an ending quad, and then a rate. Because right now, the flower term in our map declaration is equal to this 1012, but it's just that first one. So what we want is that number to update over time. And that's the other thing, is we don't want to update our map every single frame, because, I mean, I guess we could. We could update our map every single frame. It's just that this is the whole problem of me trying to do it. So like here, I'll show you in our map constants here, map declarations. So map declarations is like, hey, 1-1, level 1-1 here is just all of these sprites. So all of these, like let's say where grass is oh God, come on. come on. Okay, maybe not. Let's say grass is equal to, okay, it's not in our declarations, it's in our constants, which we have here. So all of our tiles are kind of mapped here. So it's just a number of what ID from our master sheet. So our master sheet holds everything, at least everything for our map. So the number like grass is whatever, 60, whatever. Grass is 34, so that's right here. This one right here in the center. So yeah, this was the kind of trade-off and the struggle I was doing to implement this feature, was that I didn't want to necessarily update our map every single frame. But it's such a tiny game, and the map is... We might just do that. Because it would be nice for us to just map declare a flower, and by default a flower is an animation that gets updated over time, and it'll just render the animated flower. That would be nice, but then we would have to update our map every single frame. And then I guess in our scene here, instead of just declaring, where do we do it? We initialize our current map to be this map. So instead of just one init for our scene based on the current map, in our scene update, we'd have to go, we'd have to say, you know, update our current map here, which we could do. And I guess that's since our game is so tiny, we're actually building it at Game Boy resolution, so it is really tiny. I'm gonna take out some of this old collision logic to just tidy it up a bit. Okay, so we've got, yeah, I think what's next is to rehash the animation so that we can have animated tiles. Because it'd be nice, you know, to have grass kind of blowing in the wind, or if these flowers moving like in Link's Awakening. So we will rehaul that probably tomorrow. Can you use delta time instead of each frame? Yeah, the our animation class is exactly that. I'll show you what our animation class looks like. And it's just like right here. So we're updating our animation over delta time, and we're just incrementing our current frame within a given, what is it? We have a total amount of frames that we have to define, and then it'll increment through the current frames, and it'll loop back to 1. So it'll go, you know, if there's 4 frames, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1. And then we do that in our entity definitions here. So like our gecko, for example, is if it's walking up, it's these frames, and it's this interval, so that gets passed into our animation class, and then that's how it updates the quads for the rendering. Okay, so yeah, I think tomorrow we might gut our animation spitter and kind of redo it, because I made the anim spitter class because our animation class asked for a lot of things. Like it needed a bunch of things I didn't want to have to declare for each animation sprite. So we might just make like a map animation instead of our anim spitter and have it do this similar thing. And then we'll populate our map declarations with a variable, not a constant, of whatever the animation is. And then we just need to make sure in our scene we update our map with, I guess, we would need to update our map, but hopefully updating that map. See, so like, I guess in our map declarations, we would need an update function, and it spits out an exact same table, except that if it's a variable and not a constant, it would update that quad number. So we might do that. I steered away from that because I didn't want to have to reassign every map. Because it's like, when you think about it, and especially if there's no animated sprites on the screen, we would be manually reassigning and overriding the map to what it was over and over. I'm sure there's a smarter way to do that, but I am a beginner dev, so I'm still figuring this stuff out. Let's see if... and that's why I kind of did this insert animation function, because it's like, I only wanted to declare the map once, which is why I declared it with the flower of the first animation. I declared it there once, so we're not updating that, but then we're going over and we're only placing animations and updated animated sprites on the sprites that are animated. So that was the kind of idea behind that, but it gets messy where it's like, oh, we have to declare it for every particular map row and map column. So I didn't like that about that approach. But it's all about trade-offs, I guess. It's like, do we want to just manually reassign it because it doesn't cost a lot of memory? You know, it's a tiny little Game Boy game, so it probably shouldn't matter that much. But it's tough because it's like, if we change it right now, it'll change how the whole game operates in terms of like performance and stuff, or it could. So it might be worth me just mulling over a bit more and thinking how we can update these variables, place them in only certain map objects. And the other nice thing about potentially doing it where we manually reassign the map every time is that once we say, like, let's say we wanted a flower right here, and we wanted a flower right here or something, then we would have to know in our map spitter, we'd have to go into our map scene and say, hey, if we're map 1-1, then manually put a flower animation at the 2,3 map, and then map here, as opposed to if we updated every frame, we would just put a flower variable here, and then we can move those flowers as we see fit, and as long as we're reassigning the map over time, it would just update and work. So that is seeming like the cleaner solution. I just don't like the idea of reassigning every sprite, every frame, if they're not animated. So I'll mull it over and then think about how we can do that. Yeah. But today we did get our fixed collision detection for our map objects. So maybe tomorrow also we'll just add a couple of collidable map objects like a fence or a wall or a house or something, so that we can just kind of put these little map collidables into our game, because it adds a lot of, I won't say it adds a lot of polish, but our game, instead of just walking anywhere and everywhere, which we have currently been doing, we can have these little collidable map objects, and it just gives that little extra layer of feedback to kind of, oh my goodness, look, we can't walk up. Oh gosh. That is so strange. We can't walk diagonal up. Oh my goodness, now we can. I don't know what happened there. Okay, we couldn't walk diagonally up in that scene for some reason. And you know what? There is still a hidden bug in here somewhere where we get stuck in a walking animation if we do some sort of input upon a scene transition, but I can't replicate it. So we will have to debug that at some point. I'll make a note of that so we can say, do we not have... we did this. This is what we wanted, yeah, our animation bug. Okay. Okay. We did this. Okay, and then the other thing we want to do is add a kind of pushing. Like Link's Awakening, if you push up against an immovable object, he actually pushes instead of just walks with his nose like that. And it adds a lot of character, I think. So we'll do something similar. And then eventually, you know, maybe have some pushing objects availability instead of just it being a cute thing. Maybe we can actually push items around for certain things, either puzzles or something. So we'll make note of that as well. Map, we did this. Great job. Okay, and then yeah, we'll say add pushing sprites as well as the pushing animation state, because we use a state machine to trigger all our different animations. So we would need to add those sprites and then add a animation state that checks for continuous input against a collision. And if we're colliding and our direction is pushed, then we're going to trigger the appropriate side of pushing. I think that's good. Okay. So yeah, I think that'll be it for today. Let's go ahead and check out our get diff here to see what we did. Now, all we did was change our colliding functions to be a little more verbose. We're calling it collides with a map object because we shrunk our collision detection so that we can walk in front of the tree there. And then we just added a tree to kind of prove that stuff, and then we just changed our Y and X position based on those collision detections. We got rid of some notes. We moved our Manus to only drain if we are not in a scene transition. So that's pretty good. So we'll say here that we have perspective-based collision detection. And then we'll get push it. Thanks for watching, guys. I'll be here tomorrow at 7, doing some more stuff. I'm gonna see if there's anyone we can raid here. There's this guy, programmer Jeff, who has some really cool graphics. And I'll set up a raid for him if you want to check out his raid. He does some really cool stuff. It's chatbot on Twitter. But thanks for watching, and I'll be here tomorrow.